Professor Chip White from Georgia Tech. The professor of Industrial and Systems Engineering. Used to be also department head for 5 years at Georgia Tech. He got his PhD from the University of Michigan, and he also worked at University of Virginia as well as University of. So we begin the first one. I guess your presentation is already loaded?
Yes.
Okay. All right. Go ahead. And I'm going to just sit there and come back so I can see the slides.
Well, it's a pleasure to be here. I'm sorry Paul's not here. I was looking forward to seeing him. He is a colleague, a former colleague at Georgia Tech, along with myself, and we have a new school chair that's coming soon, Edwin Romaine, and it's delighted to see him as well. Paul and Vittel asked me to talk a little bit about logistics operations from an energy generation point of view. And so I have put together some slides on the topic, and the outline is I'll talk a little bit about supply chain and logistics, because my assumption is that not everybody is all that familiar with this particular topic or this particular industry. And then talk about energy consumption within this industry. And we're going to find that by and large, the energy usage is trucks. So I'll spend some time talking about new vehicle technologies just to explain to you some of the things, some of the issues that are faced. There's no research really being presented here, just sort of an overview of what I see as the industry, and what I see are the issues associated, energy issues associated with the industry. Okay, with respect to supply chains, I do.
Oh, you found it?
Yes.
Okay, I was wondering.
Okay. I trust it's you got it. Okay. With respect to supply chain and logistics, some things that you do know, but we'll just mention them anyway. If we're talking about an enterprise, which is a company and several suppliers that parts have been outsourced to, or some function has been outsourced to, a logistics function is typically outsourced. It's really a collection of companies, independent companies that are contractually related to each other, that are trying to do something, get something to the marketplace that is marketable and can be made at a price where there can be a profit. Better, faster, cheaper. This is sort of the theme of a enterprise, and within an enterprise there's flows, things flow. Money flows, information flows, and then goods flow. And the goods part is the primary intent of this discussion and its energy implications. But information is going to have a major role in determining exactly how efficiently goods flow, and as a result, what are the energy implications and perhaps some of the information issues associated with it. To be a little more specific, think auto, if you will, or any durable goods manufacturing activity, and supply chains start out with suppliers of commodities typically, and feed parts into a manufacturer or an assembler, and from there to distribution and on to customers. This is, would be a good description of a simple description of a supply chain. Things kind of get complicated because there are very different ways of putting together a supply chain. In some case, you would want to make a lot of material and then hope that it's bought. This is called a push method of control. The emphasis there would be, what you end up with in that kind of a supply chain strategy would be a lot of inventory, typically, a lot of cars out on the lot that you're trying to sell. The transport system doesn't have to be particularly sophisticated or synchronized, and the information systems associated with this kind of manufacturing also don't have to be. These are the sort of the traditional mass production supply chain strategy that's been used, in large part because there wasn't information technology around to support anything else in terms of manufacturing. So this is a push method, mass manufacturing. Pull methods, build to order, mass customization, are now more or less becoming not a norm exactly, but certainly much more prominent in terms of supply chain design. The objective is to keep inventories down or costs down by keeping inventories down. This requires a lot of coordination, a lot of information flows, and in terms of the transport system, maybe a high service level of transport that's involved with these pull methods this is sort of the Dell method, where you order it, they take the order and then order the parts, assemble the parts, and then give it to you. It's not there, it's not in inventory, or a lot of it's not in inventory before it's actually ordered. Very fast, flexible, adaptive supply chains. Okay, a lot of data flows in this particular supply chain. Point of sales data, a variety of other kinds of data will flow back through the supply chain. Returnables, recyclable products that are perhaps used to transport the goods from the supplier to the assembler also have to flow back. This is the reverse logistics part of a supply chain. Supply chains are multi-tiered. Some suppliers have suppliers themselves, and they're first-tier suppliers, second-tier suppliers, and so forth on back through the supply chain. The objective of putting this product together, you talk to marketing to make sure that the product is going to be something that will sell. You talk to manufacturing to make sure that you can manufacture it at a reasonable price. And you talk to the designer. As of yet, there aren't a lot of people who are talking to the supply chain designer. And we hope that there'll be product and supply chain design concurrently in the future, because all of the cost isn't in manufacturing. In some cases, only a small percentage of the cost of the product, making the product, is actually in manufacturing. So at any rate, these groups get together and are involved with the design of the product. And then typically what's outsourced, one of the first things that's outsourced for durable goods manufacturing is the third-party logistics provider. This is a service provider that usually owns trucks, has access to rail transportation or air freight transportation, who coordinates the flow of the goods as they come out of the suppliers into assembly or manufacturing, and then on to distribution and to the customer. So there's this coordination activity that goes on with the third-party logistics provider, and that's often a trucking company with a logistics arm. Okay, in terms of what's happened over the years to logistics costs, logistics is usually transportation plus inventory cost. Holding inventory is expensive because you have to take out loans often to buy the material before you can sell it, and so there are inventory holding costs that go along with logistics. There's a little bit of administration cost, but we can almost ignore it, given that the big costs are transportation and inventory costs. If we look in the transportation cost, much of that is related to fuel and energy usage. As a matter of fact, which costs more, the labor, the drivers typically, or the fuel? Well, they kind of bounce back and forth depending on the cost of fuel and the wage rates at the time. Wage rates right now are going up in the trucking industry. Energy costs are going down a little bit, and as a result, there may be a switch. But they're the two big costs that, as usual, that are associated with a heavy asset service provider like a trucking company, rail, or air freight. We see that if we look at how these costs, this is deregulation in the United States, when the freight transportation industry was deregulated. And we were running at that time about a little over 16.3% of GDP was being generated by the logistics industry at the time. That's crept down. This is 05 numbers here, but it's stayed steady right around a little over 8% now. A dramatic drop in the percentage of U.S. GDP that's generated by the logistics industry. And you can see that the drop hasn't been in transportation, it's been in inventory. There are deregulation pressures that have caused this, but also just in time. You know, a new way, at least a new way of looking at the way one should go about manufacturing your products, and as a result, we see this drift down. So this is kind of what's happened over the last 20, 25 years in terms of logistics cost in the United States. If you look at other countries, depending on how much they've invested in their infrastructure, often the reason for high GDP is because you can't get through the city. You know, try to move freight through, I'd just name a city, Shanghai in China, or European cities do very well in this. As a matter of fact, Europe is not that much more inefficient than the United States. And EU and the cabotage laws that have been sort of removed have created a much more efficient European trucking industry and more generally a logistics industry. But many cities in particularly Asia, the mega cities, and where we're going to be seeing some real growth in terms of population size over the next several years, are the ones that have the congestion that generate inefficiencies in logistics and create higher percentages of GDP. China's between 18 and 19%. India is probably around 16% or so. Sometimes you can just look at the percentage and guess the country. At any rate, these are logistics costs. Inventory trends, total supply chain. This is inventory to sales ratio over a period since 1992. And you can see this drift down of inventory to sales, and this is a result of inventories getting thinner and thinner. This is just in time, migrating out of the durable goods world, transportation, particularly auto, into other sectors of the economy. You see this big blip there. That's a grand recession. That's what happens when you have recessions. You get the inventory to sales ratio jumping up. Anyway, so that's just kind of a look that tells you something about the efficiency of the logistics industry. Let me talk about different aspects of the industry itself. There are many modes. You can move goods in many ways, depending on what you're moving. If you're moving something light, and you need it fast, next day or maybe even later in the day. Then parcel, small package, you usually think of UPS, FedEx. When you see this circle right here, fast delivery, this is transit time delivery options versus shipment weight. And it typically pretty much goes like this. You get into air freight, heavier equipment perhaps that goes further. If you have a product that is expensive per pound, like a medical device, or like some electronics equipment that's made in Taiwan, you fly it because you really want to get it to market very quickly. It's an expensive product. You want to get it in the hands of a customer for financial reasons, maybe in the case of medical device, for health reasons. And so you fly it, put it in the air. That has all kinds of energy implications. We'll get to that shortly. This is less than truckload, the part of the trucking industry in the United States where the back of that 53-foot trailer is filled with several different loads going to different places. And it's a part of the industry that requires a great deal of coordination in that there's a pickup and delivery fleet as well as a line haul fleet. you pick up that refrigerator, for example, that you're shipping to Atlanta, somewhere here in Philadelphia, and it's taken to a consolidation center, put on a line haul truck, a 53-foot trailer, tractor trailer, and then at night, typically, it'll drive to Atlanta. I can't quite make it to Atlanta from here, but almost. And then the next day, it's put on pickup and delivery vehicles again and delivered. So it's a relatively complicated part of the industry. In terms of complication and complexity, it's very similar to Package Express. They're pickup and delivery vehicles that UPS has, for example, and they're line haul vehicles. You see those big 53-footers out on the road, often at night, sometimes during the day because it's more than just a local run for them. And we have similar complexity. LTL and Package Express are different in the LTL loads are typically more like 1,000 pounds. Parcel Express is under 50 usually. So you pick up a lot more here. There may be 10, 15 pickups an hour. This is maybe 8 or 10 pickups a day. So it's a different kind of problem, and the consolidation centers look quite different. If you go to truckload, the TL part of the industry, that's the part of the industry where whoever it is, let's say Walmart, can fill up the entire back of the truck. And they don't need to do pickup and delivery. They just go from A to B. It's a relatively simple part of the trucking industry, and we can see the cost per pound of truckload is considerably less than truckload. This is about a $35 billion industry, less than truckload, and we'll see that it's really relatively small compared to truckload. And then you get into rail. We know rail is very energy efficient, and large loads there. If you can't truck it, you put it on rail, and eventually you have to put it on truck to go the last mile. That's one thing railroad doesn't do very well. And then, of course, ocean, where you put it on a big container ship. And container ships can be extraordinarily efficient energy-wise in terms of moving a lot of stuff, but it takes a long time sometimes to move it relative to air. Okay, so that's kind of a snapshot of the industry domestically. Internationally, it's a little different. Let's look at I hope you can see this. If we look at modes and we look at millions of tons and the value of what's moved, and we look at 2007, 2011, and then projections out to 2040, we see that by far the dominant mode is truck. And that's the reason I will be talking about vehicles with you a little bit later. And we'll see other figures that indicate too that we can't ignore rail, and this is of course domestic water, so there's not a lot of that in the United States. In other parts of the world there is, okay, and also air. Trucking has become so efficient that what used to be a domestic air freight business is much smaller than it used to be, because the trucking industry is so efficient now. At any rate, the takeaway from this slide is that trucking is the dominant mode of getting stuff from wherever from its origin to its destination. And one of the reasons is it's very versatile. There are roads all over the place. And it can also deliver the last mile. That's something that rail can't do and air can't do. Okay. Let's talk about supply chain design. How do you design a supply chain? When you have a product, you know roughly where your customers are, and you have and you have access to at least some or all of these modes of transport. This is a private sector industry, and their focus is on minimizing costs. They don't want to take too much risk. That can be dangerous. And they want to maximize their customer service, or at least have customer service at a particular level. It's usually more of a level than a maximization. The direct costs that the industry is faced with are tariffs, tolls, fuels, personnel. And I mentioned that fuel and personnel are the two big ones. in particularly the trucking industry, but it's true of the other parts of the freight transportation industry too. There are indirect costs. The indirect costs are related to lead time, being the length of time it takes to go from origin to destination. And there are two contributors to cost, indirect costs there. One is how long it takes on average, and then how variable it takes to get from origin to destination. What this affects is how much buffer inventory you have to have, safety stock, if you will, which creates holding costs. It's kind of an indirect cost that can be quite expensive if interest rates are high, which they're not right now. And that's in order to satisfy customer service. You have to have enough in inventory. So one of the reasons why there may be fast supply chains is to keep down holding costs. And that's one of the reasons why you may want to fly it rather than put it on the water if it's coming from, say, Southeast Asia. It depends on the product. It depends on the corporate strategy. It depends on a lot of things in terms of how you build your supply chain, what your supply chain strategy is. Okay, all modes are of interest. If you're getting that part from somewhere right outside of Shanghai to Detroit, an auto part, it has to move by truck for a while, or rail. It has to move by typically water, and then it'll come to perhaps a port on the West Coast. It gets transferred to rail or truck. Usually at that point, if it's going to Detroit, it would be rail. And then eventually it gets to truck and onto the assembly plant. So most moves are intermodal, at least for international supply chains. If we're redesigning the supply chain, if we have a supply chain, it's not optimal and we want to adjust it a little bit. Reasons, fuel prices have gone up or sales have gone up. Some kind of adjustment is needed in order to bring the supply chain into and synchronize it with customer demand and cost. It usually results in modal or intermodal shifts if you're trying to save money. And you might put it on a large container ship rather than a faster ship, or you might rail it rather than truck it. The financial reasons are related to changes in energy cost, infrastructure, regulations, mode availability, and a lot of other reasons. Okay, implication, all modes and their interfaces are part of the system, of this vast network of systems that move freight domestically and internationally. Okay, well, what are some externalities and constraints? We've already mentioned several of them. Energy and labor costs are the two big ones, and it's not only cost but availability. Right now, there's a driver shortage in truckload, and that is affecting less than truckload and other parts of the industry. Truckload typically has loads of about 10,000, 17,000 pounds each load, whereas less than truckload has 1,000 pounds. If the truckload industry has more capacity than it has business, it's going to start creeping into LTL business. It'll start taking lighter loads, 5,000, 6,000 load trips, and they'll run something called milk runs. So there's always a little tension between the barriers of these parts of the trucking industry. Regulation is a big issue. EPA, hours of service, how long a driver is allowed to drive, is always a point of argument between the industry and the regulators, the feds. Size and weight. I'd like to, instead of 53 feet, if I could run a trailer that's 58 feet, I could be much more energy efficient, et cetera, and it would be better for the nation, certainly better for my trucking company, okay? Well, that's okay, but there's safety concerns that get involved, and this is an industry that's very concerned about security. All kinds of things get moved the companies wish weren't on their trucks, and sometimes they can be quite dangerous. A lot of hazmat gets moved, but sometimes these are potential delivery systems for weapons. Okay, let's talk about some trends in the industry very quickly and touch on the energy implications of those trends. Big data, value of information, real-time supply chain control and based on real data is a trend that is just really dominating the industry right now. There's a lot of IT in the industry. Automation is also a major kind of activity. Driverless trucks are within 3-5 years, maybe of right now. It's not clear. Changing demographics, the rise of the mega cities, urban logistics and congestion definitely have an impact, an energy implication to this trend, and it's in the sort of the negative. It's going to takes more energy to move through a congested city than one that's not congested. Changing customer demands. Huge middle class is developing in Southeast Asia, for example. And this middle class has money, knows what e-commerce is, wants things that the world's population didn't want as much of 10 years ago. So this trend is going to have an implication of moving more stuff and with a tighter level of customer service. I want it later today. I want it tomorrow. This is the e-commerce that's causing Amazon. It's causing redesigns of supply chains in order to be faster, not cheaper, not more energy efficient, but faster. Why is Amazon doing what they're doing? Is because they're dominating e-commerce right now. They have about 3% of that industry, that business, and soon the rates will go up. They're not making any money right now, but they're really gaining market share and capturing a market. Okay, so that would be the fourth one, and some of the energy implications of them. Changing infrastructures, physical information vehicles. Presumably, we are having less, the new infrastructure as it gets larger and more efficient is going to improve energy efficiency. The new set of locks, new third set of locks for the Panama Canal, for example, will allow goods coming out of Asia to all water shipping to the East Coast, to Philadelphia, New York, New Jersey, Savannah. And as a result, it may significantly improve the energy footprint of those moves. That's on the good side. The other trends that we've discussed are not so good. Energy and sustainability, of course, is what we're talking about. New manufacturing and freight transport innovations. Additive manufacturing should require less tonnage moved, and if the whatever you make, whatever the feedstock that the 3D printers or the additive manufacturing devices use can be made into a lot of things, you can enjoy economies of scale, and as a result, overall move less goods. Also, what you're moving is feedstock and information as opposed to work in progress or final product. And as a result, there are a lot of other implications for the freight transportation industry. But this should be on the plus side of the ledger in terms of energy usage. New practices in supply chain designs that are very information intensive, the pull supply chain, build to order, mass customization. This has a tendency to be perhaps more efficient in some ways and perhaps not so efficient in others from an energy point of view. Changing regulatory environment, we've sort of mentioned that. At any rate, these are some of the trends that we're seeing and how they, some of them might affect energy usage in a positive way, and some might affect energy usage in a not so positive way. Okay, let's talk about energy consumption in the industry. Energy consumption by freight transportation mode. It's trucks. 2/3 of the energy that's required is used by freight transportation in the United States is really trucks. So this is what we can kind of focus on. It's interesting, we think of the rail industry as being a big industry. We all know what rail is. How about less than truckload? We introduced that term. Some of you are familiar with it, some of you are not. Less than truckload is a larger industry than the rail industry in the United States. And truck is both for hire and private fleets here. This is, we're considering on both the fleets that are owned by companies. Walmart has a fleet of 8,000 trucks. I mean, there's a lot of trucks that Walmart uses. They also outsource a lot of their freight transportation. If we look at transportation modes as a function of energy usage, these are rules of thumb. It's not an accurate interpretation, but it's kind of a rough idea that 8 times more fuel consumed and greenhouse gases emitted if you fly it per mile, per ton mile, than if you truck it. However, you rail it, you get a 4 times decrease, roughly. Okay, we're not going over the Rockies here. Okay, we're just, you know, in a relatively uniform way going across the United States. And if we put it in water, there's another 3% or 3 times decrease. Now that boat, if that ship, brother, that's not a boat, that's a ship. If that ship is a large container ship, 12,000 TEU ship, 18,000 TEU ship, that 3 gets much bigger. Okay, so at any rate, this is a rough idea of what you trade off from an energy perspective when you change modes. And also change costs, and you change the length of time, the amount of time it takes. Why would we choose one mode over another if it's so much less expensive to rail it than truck it, for example? Trucks will get there faster. That decreases your holding cost. So overall, from a cost point of view, the manufacturer may prefer to truck it. Okay, some background. U.S. Transportation sector accounts for about 28%, this is U.S., greenhouse gas emissions and 28% of total U.S. energy consumption. These are relatively new numbers. About 5% of the total energy consumption in the U.S. is used for operating heavy trucks. Heavy trucks are the Class 8 trucks that are tractor trailers with a 53-foot trailer on them, but also some of the heavier trucks that are straight trucks and maybe have shorter trailers on them and so forth. But that's a pretty significant number. It's one of the reasons why you know, we see this part of the industry generating a lot of, or needing a lot of energy, and then we see what within the industry is needing a lot of energy, and we can just really focus on trucks, at least in the U.S. and pretty much everywhere else in the world. Logistics industry is focused on reducing energy consumption and greenhouse gases. Yes, they want to be good citizens. There's no doubt that you know, they're interested in that. However, at the end of the day, the industry has to make money. So they're focused on cost. As long as cost and energy usage are aligned, which most often they are, then you'll get good citizens doing what they would like to do and not violate their concern for going out of business in the next couple of months. So EPA and NHTSA have recently set fuel consumption standards. They do this EPA does this every 3 years. For trucks, this is the Class 8 tractor that pulls the tractor trailers. And they set other standards as well, but that's really where we're focused on. DOE has initiated a National Clean Fleets Partnership. EPA has initiated a Smart Way. There are all kinds of programs that are being developed, and many commercial companies have you know, energy plans and eco-friendly business strategies. They're very interested in that, but again, at the end of the day, they have to be solvent. Let me give you an example, a couple of programs. The Smart Way program, it's a public-private initiative between EPA and the private sector. And a SafeStack, which is a cargo loading system that makes better usage out of the back of a truck But in so doing, it means that you have less trucks on the road, and it has energy as well as safety implications that are positive in both ways. And we can take an example, a company. Conway, third largest less than truckload company in the United States. A company that I happen to know well. It's a Fortune 500 company. It's traded on the New York Stock Exchange. It has a, freight company. Freight is a term that means less than truckload. A truckload company, and then a logistics company also. And Menlo is all over the place, all over the world. And they have, the fact that there are two of these things, they're called PUPs, mean that this is a less than truckload move. The fact that this doesn't have a cab, a sleeper cab, means it's a less than truckload company. This part of the company is, okay? This is an example of a company that has about 8,400 trucks, 22,000 employees, third largest trucking company in the United States for less than truckload. One of the largest truckload companies and one of the largest logistics companies in the world as well. What do? They have been involved with SmartWay Excellence Awards from EPA. They've really focused on getting their carbon footprint down. Why? Because it saves them money as well as it's good for the environment. They have something called SafeStack. They're actually a leader in using SafeStack. We're looking at the back end of a truck now, a rear loader, not a side loader. And what we have here is another floor. Here's the basic floor. Here we have some stacks here. And these are pallets, perhaps, that you don't want to stack on this because it might crush them or damage them. So you put in another floor. It's called SafeStack. And you strap in the pallets. It takes a little longer to load, but you can move almost twice as much, particularly depending on the product and the fact that maybe you cannot put pallets on top of it. Okay, now that saves money. It saves fuel. It also safety, because instead of running two trucks, you're only running one. So your risk there, you're mitigating risk. And this is an example of a company that is doing, I consider, a fine job of trying to be environmentally friendly and at the same time being a good trucking company. New vehicle technologies. Okay, I hope I've convinced you that tractor trailer truck that's going down the highway, I-95, is a huge, it uses a huge amount of energy if you add them all up together. And this happens to be the focus of what I'll be talking about here. New vehicle technologies. If you look at factors affecting truck fuel economy, we can just read them off. Driver, how well the driver drives, okay? Idling, they will idle a lot. I mean, if you're sleeping in your cab at a truck stop and it's cold out, you idle your engine to keep you warm. And that can generate a lot of extra fuel usage. The weather, depending on what kind of winds you have, aerodynamics are very important for this type of vehicle. Tire inflation, load, route, speed. As we go around the circle here, you see the big number. It's the driver. Whether the driver is using a brake a lot and accelerating a lot. These are diesel engines. And as a result, if you can train your drivers to drive more economically, use less fuel and so forth, keep your gallons per mile down, then this is a major source of the impact on your bottom line and on the environment. Idling, there are ways of reducing this without using the diesel engine that drives the power unit. And weather, headwind, tailwinds can make a big difference in something that has this much of a face to the wind if you have a headwind coming on. Same thing with airlines. Okay, tire inflation, if you keep your tires inflated. We'll talk about tire design in just a minute and the importance of it in terms of reducing gas fuel mileage. The load, 80,000 pounds is you're hitting a regulation when it's a weight regulation with a 53-foot trailer on your truck. 70,000, the load can make a difference, but not a whole lot of a difference. It's really better to keep, from an environmental point of view, to load the truck up if you can. And sometimes you can and sometimes you can't. The route, you know, if you're, they're three-dimensional routing now. If you can take a little longer but not have to climb hills, you don't have to have a more powerful power unit, which doesn't give you the same fuel mileage that a lighter engine would require, and you end up saving fuel by maybe taking a slightly longer route as you go through the Rockies. Okay, if we look at where energy is distributed and generated by the truck, this is a modern long-haul Class 8 vehicle. This is the tractor and trailer, that 53-foot trailer with that can carry up to 80,000 pounds. Well, the fuel usage obviously is going to be a lot of, it's the engine, but look at the other areas. Tire rolling resistance, very important, 16%. That's a huge percent. Aerodynamics, 19%. These are the big three, essentially, when you're trying to get your fuel mileage down. If you look at tires, there's been a lot of research on tires. It turns out, I don't know much about tires, but you know, the tread, as we'd expect, is going to create about 60% of the design of the tread has a major impact, of course, on fuel usage. But there are other parts of the tire. This is information from Goodyear. Energy, of course, and aerodynamics of the tractor is very important in how that tractor sort of mates up with the trailer. If we're looking at different kinds of power units, we're looking at hybrids. Now this is this actually is an automobile that is a Volkswagen hybrid unit, but it's being designed for small trucks as well as maybe being extended into larger trucks. If we look at sustainable powertrains, there seems like there are two directions. One is combustion power, where you use a hybrid kind of vehicle, and then there are electric power vehicles also. In Atlanta, there are a lot of hybrid vehicles running around that UPS has. They're pickup and delivery fleet. And it's a very interesting sort of experiment that UPS is running with its delivery fleet in Atlanta. Okay. If we look at options for future technologies and energy sources, you know, we are in diesel, natural gas, and gasoline here, but there are all kinds of other fuels that you're familiar with that have been that have you know, different footprints in terms of their energy impact. And this is not only restricted to trucks, but also to locomotives. The hydrogen fuel cell switch locomotives. Switch locomotive is a locomotive in a freight area that is changing, building trains and taking trains apart for long runs, a switch engine or a cut engine. Update, as of the 3rd of September, there's something called the North American Council for Freight Efficiency, and they do a benchmark study. Their fleets represent only a small portion of the fleets in the United States, but there's a lot of trucks out there, and 2.5% of all the trucks that are out there is a pretty large number of trucks. Their fleets, this is for a 53-foot trailer, Class 8 tractor trailer. They're getting 6.77 miles per gallon. for these things. Now, that may not sound much to you. This is something that's pulling about 96,000 pounds. And it's a remarkable feat. A couple of years ago, it was rare, this may be 3 to 5 years ago, it was rare for these vehicles to get over 6 miles per gallon. And what we're seeing is that this represents about an 8% increase since of fuel mileage since 2011, according to this council. Now, what are the implications in a 1% reduction in fuel use? It's a savings of about, a $250 million gallons of fuel, maybe $1 billion a year at the cost of diesel. Now, so it's not insubstantial for the industry. Remember, this is only 2.5% of the industry, and it's just the trucking industry. So it's significant in terms of impact, environmental impact. That's really quite significant. 6 categories of fuel efficiency technology. Idle reduction, we won't worry about chassis because I haven't talked to you about chassis. But those, you put containers on chassis, and if those chassis aren't taken care of and maintained properly, they can generate an awful lot of inefficiency in terms of hauling things, particularly on ports. Various practices like how your drivers drive, how you maintain your fleet. Tires and wheels, that's a big issue, as we've seen, tractor aerodynamics and trailer aerodynamics. Frequently used technologies include tractor chassis skirts. You've seen them on trucks probably. And it turns out they're effective. Lighter tractors, lighter trailers, and automatic transmissions. Automatic transmissions shift a lot better than even seasoned drivers do. So anyway, this is a little bit of an update in terms of what the industry is trying to do to be more fuel efficient and have less of a footprint environmentally. So that's a real quick overview of a couple of topics about the logistics industry, its energy usage, and some of the things that are being examined, looked at to improve fuel efficiency and minimize the environmental footprint of this particular industry. So thank you.